the first part of solving a system of equations using matrices is being able to take a system of equations and write a matrix equation. So, given this system, we are going to write a matrix equation. So, essentially what we want to do is take the coefficients on the left-hand side of the equal signs. And to do this, the first thing you have to make sure of is that all your x values are lined up like this, all your y like this, your equals, and then your coefficients or your solutions on the end. Just like in when you would solve for, using the elimination method. So you're going to take those coefficients and you're going to create a matrix. And in this case, it's going to be a 2 by 2. 3, -7, 5, -8. Now, we can't forget the fact that x and y are part of the system, but they are the unknown values, so they are their own separate 2 by 1 matrix. And then notice how in between those two matrices implies multiplication, and they equal our solution matrix. Now, you can't plug this into the calculator the way you see it, so I'm going to write how you would plug it into the calculator. So in the calculator, you're essentially going to take this 2 by 2 and this 2 by 1 and combine them, which would make it a 2 by 3. So you would have 3, -7, 5, -8, and then the solution side, 25 and 27. Now, in your calculator, you can't separate them. Sorry about that. But I like to put a dotted line here to imply that this side is the part that I'm solving for, and this is my solution side. Because after you complete the steps to solve using the calculator, your solution is going to be on this side, and this left side you're about to see is what's going to confirm that you are doing it correctly. So I want you to take this 2 by 3 and plug it into the calculator. So let it denote, we'll call it matrix A, the first one in your calculator. So after you have it in your calculator, you're going to hit the matrix button, so second, x to the -1, and then you're going to go over to the math column. And underneath this math column, you're going to arrow all the way down to your option called B. And it's going to look like this, RREF, with the parenthesis. This stands for row reduced echelon form, which is essentially the steps of how you would solve a matrix if you were doing it by hand. So you're essentially telling the calculator, hey, calculator, do it for me. So when you hit enter, you're then going to have to go back into your matrix and choose matrix A, and then hit enter. So what you should see is this. You should get another 2 by 3 matrix, except you should see the identity matrix on the left side of that invisible line, and then the values -1 and -4 on the right side. So what this is saying is, since x up here was in our first, our top line, our top row, that's what x equals down here in our solution, -1. And since y is on the bottom row, that's what -4 is. Now, the only way this is the solution is if you get the identity matrix over here on the left. If you get anything but the identity matrix, it is not the solution. And you're going to see an example like that in a little bit, but know that it has to be exactly the identity matrix of a 2 by 2 or the 3 by 3, depending what we're dealing with, for this to be your answer. And since it is a coordinate point, we're going to write -1, -4 as our solution. Okay, so this is our second example, and the thing that I see the most is the fact that none of the variables are lined up and it is not equal to a coefficient on that right-hand side. So I'm going to take negative 7y to the other side by adding it. So I'm going to have 8x plus 7y equals 5. And then, I don't even think I wrote this correctly. This should be 4x here. And then I'm going to add 4x to both sides and write it first so it's in line with my other x. And so now we can write our matrix equation. Okay, so the equation. We're going to have our 2 by 2 matrix on the left of the coefficient, made up of the coefficients. So 8, 7, 4, and negative 9 times x and y, because those are our unknown values, equals 5 and 65. Now, I know we're not doing anything with this equation in our calculator because we go one step further to use the calculator, but you still need to know how to write a matrix equation. I might ask you on a test to simply just state the matrix equation, which would be what you see in red. But since we're solving and using the calculator, I then want to take this equation and make it into what's called an augmented matrix, meaning the solution is part of the matrix. So we have our 2 by 2, 8, 7, 4, negative 9. And within the same matrix, we have our solution side, 5 and 65. So you go to that math. In matrix, you go to that math column. Option B says RREF, and that's what you want to choose. And whatever you call this, again, like if you overwrote it and you said it was matrix A, plug in matrix A. And when you do this, you're going to get the identity matrix on the left. So you'll get 1, 0, 0, 1. And then you will get 5 and negative 5. So like stated before, x is in our top row, and so is 5. Y is in our bottom row, and so is negative 5. So our final solution is 5, negative 5. And since this is a system, what you can do is take that coordinate point, plug it in to see if it satisfies the original system of equations. Okay, so our third example, it has everything nicely lined up. So I'm going to go straight to the matrix equation, which will be 2, 2, 1, 1 times x, y equals 10 and negative 2. So in the calculator, you're going to type in 2, 2, 10, 1, 1, negative 2. So after you do RREF of this matrix, again, we're going to call it matrix A, you actually get out something that looks a little different. So when I do this, I get 1, 1, 0, 0, 0, 1, just like this. Well, on the left is definitely not the identity matrix. So that does not mean x is 0 and y is 1. No way. You need the identity for this to be true. So what this tells you is that you have no solution because you don't get the identity matrix. Can you have a system of equations that has no solution? Absolutely. Parallel lines. And if you take a look at this and say we did elimination up here, you're going to end up with positive 2x, negative 2x, positive 2y, negative 2y, which is going to cancel to give you 0. And then you add the other side down, you're going to get what? 0 equals 6? Well, that's no solution. So this is what it looks like for a matrix to be no solution. Okay, so now we're given a system of equations that has x, y, and z in it. And it's really not that much different, especially since you're using the calculator. You did not have to solve a system with 3 variables by hand, but in the calculator, it follows the same steps that we've been going over. So, first things first, let's write this as a matrix equation. So everything's nicely lined up except the fact that there's no x value here, which just means that's 0x. Okay, so when we go to make our matrix equation, you're going to put 0 in that place. So we have -3, 6, -4. I'm going to do just the left-hand side first. 1, -4, 2, 0, 8, -1. Okay, so this is multiplied by x, y, and now z also, which is fitting because we have 3 solutions on our right, 8, -3, and 0. So in the calculator, now instead of being a 2 by 3, it's just going to be a 3 by 4. So we have -3, 6, -4, and 8. 1, -4, 2, and -3. 0, 8, -1, and 0. Same thing, R, R, E, F. And then, assuming we called it matrix A, this is what you will get. You will get the identity matrix, but instead of it being a 2 by 2, it's a 3 by 3, which is still the identity matrix. And then you get -1.8, -0.1, and -0.8. So I'm actually going to write the solution over here on the left-hand side. So as a coordinate point, it would just be x, y, z. For those of you who are wondering what z is, it's actually an axis, which creates 3D or three-dimensional figures. So instead of having y go up, or excuse me, y goes up like you know, x goes left and right, and then your z-axis actually comes straight at you. So it's coming towards you through the paper. So you would write it as -1.8, comma, -0.1, comma, -0.8. You could also change it into decimals fractions if you'd like.